I'm Anil Kumar, and now let us learn basic steps to sketch a rational function. The question is, sketch graph of the function f of x equals to 4 over x squared minus 4. Now the steps here are, first write it in factored form. So when you write in factored form, you can write this function as f of x equals to 4 over, this is difference of squares. I could write this as x plus 2 times x minus 2. Now as you can see, writing in factored form helps. We can immediately find what are the restrictions, right? In this case, the restrictions are that x should not be equal to plus minus 2, right? Now once you have the function here, you can find out where are the vertical asymptotes. So the vertical asymptotes are at x equals to minus 2 when is x plus 2 equals to 0, or at x equals to plus 2. So these are my vertical asymptotes. Now let's consider horizontal asymptote. Now since the degree of numerator is 0 and the degree of denominator is 2, the horizontal asymptote should be y equals to 0. Whenever the degree of denominator is higher than the degree of numerator, x-axis is your horizontal asymptote. You can look at the other way also. It is kind of 4 over x squared. If x is very large, then 4 divided by a very large quantity will approach 0. So it is approaching 0. Now a few other important points are x-intercept and y-intercept. Of course, since horizontal asymptote in this case is 0, in this case we do not have an x-intercept, but we do have a y-intercept. Y-intercept is the value of the function when x is equals to 0. That is, f of 0 is the y-intercept. If I write 0 here, I get 4 over minus 4, that is minus 1. So that becomes the y-intercept for us, correct? Now x-intercept is not there since numerator can never be 0. Numerator is 4, right? So therefore there is no x-intercept. So let me write down here, x-intercept is none, right? So there is no x-intercept for the given function, right? Now with this in mind, what we can do is we can find out few more points. Most important point in this case will be midway between 2 and minus 2. These are two vertical asymptotes. Midway between them is 0. When you add them, 0. So if I write f of 0, which is minus 1, that could be our maximum, right? So that's a good point to look. Now I think with these parameters, we can actually sketch the graph of the function. So let's begin by making our axis, x and y. Now I'm making a very rough scale here. Vertical asymptotes are at plus and minus 2. So let us say this is our minus 2 vertical asymptote, and here we have a vertical asymptote at plus 2. So these are the two vertical asymptotes. These are at plus 2 and minus 2. At 0 we get a point minus 1. So at 0, let us say this is minus 1 for us, minus 1. So that's the point at 0. Now we also understand that horizontal asymptote is y equals to 0. So this is our horizontal asymptote. Now we should see how will the function approach horizontal asymptote. That is to say, if I write a positive large value for x, let us say 1000, in that case what will be the value of this function? If I write 1000 here, in that case it will be 4 over 1000 square minus something, which is definitely a positive thing, right? So when we are approaching horizontal axis from the positive side, we are approaching from the top, right, like this. If I write minus 1000, even then minus 1000 square will be positive. So we are approaching from the positive side, as you can see here, right? So both ways we are approaching from positive side. Now to find few good values, we can have x values close to minus 2 or plus 2. right? So if I take a value minus 3 here, so at minus 3 we'll have 4 divided by 9 minus 3, which is 4 divided by 5. Approximately 1, 4 divided by 5 will be positive. So let's say this is our value at minus 3, 4 divided by 5. Similarly, if I take plus 3, I will get the same value, right? So we get few points here. These points will help us to draw the function. So we can draw this function kind of like this on this side and kind of like this on the other side, right? So it has to be like 1 over x graph. In the middle, if I take any value which is less than which is less than 2 but more than minus 2, in that case the value of this function is going to be negative. It will, however, have maximum value of minus 1, right? If I write 1 here, I get 2 times, if x is 1 here, so for x equals to 1, for example, or minus 1, if I write 1 here, 1 plus 2 is 3, it is 1 minus 2 is minus 1. So it is 4 over minus 3, so kind of less than minus 1, right? So it is 4 over minus 3. For x equals to 0, it is 4, right? So 4 over 3 will be slightly more than 1, so it will be kind of here. So these are other points. Joining these points, we'll get a graph which will be like this here, approaching negative infinity. So we'll have a rational function which will be divided into 3 parts, where each part will be kind of 1 over x types. Do you see that? Now the function is increasing in the interval from minus infinity to minus 2 and from minus 2 to 0, and is decreasing in the interval from 0 to 2 and from 2 to infinity. But that is how our function is going to look like, right? So let me write down this value, which is kind of important for us, minus 1, right? Now from here we can write domain of the function, right? So what is the domain of the function? Domain is x belongs to real numbers where x is not equal to plus minus 2, and then we can write range of the function, and range of the function is y belongs to real numbers where y is not equal to 0, and what else? Y is greater than 0, y is greater than 0, and in this case y is less than equal to minus 1. That is kind of important for us to understand. So there is no y value between minus 1 and 0, right? So either it is greater than 0 or it is less than equal to minus 1. So that becomes the range for the function. As I was saying, interval of increase for this function is from minus infinity to minus 2, then from minus 2 to minus 1, correct? And interval for decreases from decreasing from 0 to, I'm sorry, it should be 0 here, right? Interval from decreasing from 0 to 2, and from 2 to infinity, and from 2 to infinity. That is there. Then we can also give interval when the function is positive. When f of x is positive. So when is it positive? It is positive in the interval minus infinity to minus 2 and from 2 to infinity, right? So that is union, and negative in between. So we can write negative when it is between minus 2 to 2, right? These brackets says that they are not including these points. So these are a few more characteristics which we can add once we sketch our graph, right? So looking into this function, what we understand from here is that first you factor the denominator to figure out when do we have restrictions. In this case we have two vertical asymptotes, one at plus 2, the other one is minus 2. Since the degree of the denominator is higher than that of the numerator, y equals to 0 is our horizontal asymptote. Then we have a local, in this case, maximum at x equals to 0, y is minus 1. And after sketching, we can find out interval of increase and decrease and the interval when the function is positive or negative. I hope all this helps you to understand how to sketch a rational function. Thank you.